The Roman poet and philosopher Titus Lucretius Carus was observing the dust seen in sunbeams coming through a window. He observed that the dust particles or pollen grains, which he referred to as dancing particles, in the sunbeams are affected by air movements. He described this phenomenon as the spontaneous random movement of small particles in the 1st century BCE in his poem De Rerum Natura. His poem is translated to English in this book on the nature of things. Scientists now refer to the random movement of small particles as the random walk of the particles. In 1828, the Scottish botanist Robert Brown was observing pollen granules suspended in water under a microscope. He discovered that the motion of the granules is the same random spontaneous movement. So he concluded that this is the random walk of particles, which was later termed as Brownian motion in his honor. This spontaneous and random motion leads to diffusion as the pollen granules move through the medium, which is water in this case. The pollen granules interact with the water molecules, crashing or colliding into them and changing their direction. Over time, these random movements will cause the pollen granules to disperse or spread throughout the water. Can you see how one pollen granule keeps changing its direction while colliding into water molecules and diffusing through the water? So that's a little history behind how we started to understand about diffusion. Now let's learn it simply using some scenarios. So if someone accidentally releases a smelly gas like ammonia in your lab, the students who are the closest will get the smell first. But after some time, the whole lab will smell like ammonia. So when the ammonia gas is released, the ammonia particles collide randomly with the air particles, which changes their direction and helps them to diffuse throughout the lab. Diffusion is the spreading out of particles or the movement of particles from where they are at a high concentration, which means there are lots of them in a certain volume, to where they are at a lower concentration, which means there are only a few of them in a certain volume. So diffusion basically means that the particles move from high concentration to lower concentration. Let's look at another similar scenario. When someone sprays a perfume inside a room, everyone in the room will be able to smell it within a few seconds. Why does it take this long though? Why can't everyone in the room get the smell instantly? So what happens is that each perfume particle bounces off air particles on its way. This spreading of perfume particles into the air and reaching all corners of the room is through a process known as diffusion. So once again, diffusion is the spreading out of particles or the movement of particles from where they are at a high concentration, which means there are lots of them in a certain volume, to where they are at a lower concentration, which means there are only a few of them in a certain volume. So diffusion basically means that the particles move from high concentration to lower concentration. Good job! You learned about diffusion. You learned that diffusion is the spreading of particles from a high concentration to low concentration. Now let's learn how diffusion takes place in gases. We are using the experiment between bromine and air to learn this. So simply in this experiment, 2 gas jars are taken and the bottom gas jar is filled with bromine gas. This bromine gas diffuses upwards, filling up both the gas jars. Now let's understand this experiment a little better. First of all, the apparatus shown is set up using 2 gas jars. The bottom gas jar is filled with bromine gas. If the lids are removed, the brown color of bromine diffuses upwards until both the gas jars are uniformly brown. The air particles also diffuse downwards. The bromine particles and air particles move around at random to give an even mixture. Both the gas jars contain air and bromine particles. The same experiment is repeated with hydrogen this time. The apparatus shown is set up using two gas jars. The bottom gas jar is filled with hydrogen gas this time. If the lids are removed, the colorless hydrogen gas diffuses upwards and the air particles also diffuse downwards. Since hydrogen is a colorless gas, we have to put a lighted splint in the end to find out where the gases have gone. Although hydrogen is less dense, it will not all go to the top jar. Hydrogen will spread evenly in both jars, so we will get identical explosions from both jars. This experiment must be demonstrated in a fume cupboard. Eye protection and chemical resistant gloves must be worn. Seek urgent medical attention if any breathing difficulties occur. Now let's learn how gas particles that diffuse travel at different speeds. We will use the experiment between ammonia and hydrogen chloride to learn about this. In this experiment, ammonia and hydrogen chloride gases react to give a white solid ammonium chloride. The word equation is ammonia plus hydrogen chloride gives ammonium chloride. Chemical equation is NH3 plus HCl gives NH4Cl. How the apparatus is set up. Cotton wool soaked in concentrated ammonia solution, that is, as a source of ammonia gas. Cotton wool soaked in concentrated hydrochloric acid, that is, as a source of hydrogen chloride gas. These cotton wools are then placed in the ends of a long glass tube with rubber bands to stop the poisonous gases escaping. Then ammonia particles and hydrogen chloride particles diffuse along the tube. What you can observe, a white ring of solid ammonium chloride forms where they meet. The white ring of ammonium chloride takes some time to form. This is because it takes some time for the particles of ammonia and hydrogen chloride to diffuse along the tube, and the white ring also appears closer to the hydrochloric acid end. So what happens? Ammonia particles are lighter than hydrogen chloride particles and therefore move faster. The relative molecular mass of ammonia is 17 and of hydrogen chloride is 36.5. The ammonia particles travel further in the same amount of time, which means that the ring forms further away from the ammonia end. So this is how this experiment looks like when performed in the lab. Can you see how ammonia and hydrogen chloride gases travel along the glass tube and react to give a white solid ammonium chloride? There are some safety precautions that we need to take while conducting this experiment. The experiment must be performed in a fume cupboard. Use eye protection. Avoid skin contact. Avoid inhaling any fumes. Well done! Now let's learn how diffusion takes place in liquids. To learn this, we will use the experiment between potassium permanganate and water. You can also see how solid potassium looks like in the picture. This experiment is carried out to demonstrate diffusion in liquids. How the apparatus is set up. A small jar of strongly colored potassium permanganate solution is placed in a large gas jar filled with water. This apparatus is kept completely still to observe diffusion. Observation. It takes days for the color to diffuse throughout the water. What happens? The particles in a liquid move more slowly than the particles in a gas. The particles in a liquid are much closer together than those in a gas, and so there is less space for the particles to move into without colliding with each other. So now let's see how the small jar of strongly colored solution is made. 0.01 grams of potassium permanganate is added to 1 cubic centimeters of water. A concentrated deep purple solution is made, so each drop will contain a lot of potassium permanganate particles. So we are going to dilute this strongly colored solution, that is 0.01 grams of potassium permanganate, in 1 cubic centimeters of water by adding this solution to a larger beaker and adding water until the total volume of this solution is 1000 cubic centimeters. If we dilute this solution by adding water until the total volume is 1000 cubic centimeters, you will still observe a light purple color. This is because each drop still contains potassium permanganate particles, but the number of particles in each drop will be much less. So 0.01 grams of potassium permanganate in 1 cubic centimeters of water is a very concentrated solution, which we diluted into 0.01 grams of potassium permanganate in 1000 cubic centimeters of water, which is a much diluted solution. So what has happened is the particles have moved from a high concentration to a lower concentration, which is diffusion. You have learned about diffusion. In this lesson you learned a brief history on diffusion. Diffusion is the movement or spreading out of particles from high to low concentration. We saw how diffusion takes place in gases and in liquids. We learned how particles travel at different speed. When they diffuse, lighter particles travel faster. We learned how particles diffuse slowly in liquids compared to gases because the particles in a liquid are much closer together, so there is much less space for the particles to move into without colliding with each other. If this video helps you, then press like and share it with everyone you think this could be of help. Don't forget to subscribe to our channel to get notified about the next video.